Hi guys, welcome to my channel. In this video, I will be covering complete unit 4 in DAW subject. I will explain each and every topic in detail and I have uploaded complete DAW subject tutorials. I will provide link in description, you can watch from there. Let's get started. At first I will explain what is greedy method. When compared to all algorithm approaches, this greedy method is very simple and straightforward method. Greedy method is a technique in which decision is taken on the basis of current available information without worrying about the effect of current decision in future. Meaning of this is, greedy method will take decision based on the current available information. Based on the current available information, this greedy method will take decision. It do not worry about the future. I will give one example so that you can clearly understand this meaning. This is example. There are two nodes, node A and node E. I want to travel from source to destination. Source is nothing but where I am at present, and destination is nothing but where I need to reach. I want to travel from source to destination in shortest distance. This is condition. There are three ways in which we can travel from source to destination. There are three routes, that is from A to B and A to C and A to D. There are three ways in which we can travel from source to destination. From A to B, distance is 3 kilometers, for example. From A to C, distance is 5 kilometers, and from A to D distance is 7 kilometers, and from node B to E distance is 1 kilometer, and from C to E distance is 2 kilometers, and from D to E distance is 3 kilometers. This is example. Condition is travel from source to destination. We need to reach from source to destination in shortest distance. This is condition. In greedy method, decision is taken based on the current available information. That is, current available information is this: from A to B, from A to C, and from A to D. This is current available information. Whereas this one is future information. Among the current available information, we need to pick best result. That is, which is shortest distance among this. From A to B distance is 3 kilometers, and from A to C distance is 5 kilometers, and from A to D distance is 7 kilometers. Among this, 3 kilometers is very small distance, so I am picking this. From A to D, I am choosing this route, that is from A to B. Among the current available information, 3 kilometers is best, so I chosen 3 kilometers, that is from source A to B. After A to B, I need to travel B to E in order to reach our destination. From B to E distance is 1 kilometer. Total 3 plus 1, that is 4 kilometers. It took 4 kilometers to reach from source to destination. Greedy method is a technique in which decision is taken on the basis of current available information. As I already said, we took best result based on the current available information without worrying about the effect of current decision in future. So whatever the current decision we took, it will affect future decision. For example, I took 3 kilometers. This is current decision. It will also affect our future decision, that is from B to E. So there is no guarantee that there will be best result. So there is no guarantee to get best result because we took decision based on the current available information. For example, from B to E distance is 12 kilometers. Then it will become worst result because we saw only current information. Future information may be worst. So result is not always best in greedy method. These are the examples in greedy method. There are two examples. In example 1, I need to travel from source to destination, that is from node A to node C. In greedy method, we will take decision based on the current available information, that is from node A to B distance is 4 kilometers, from A to C distance is 7 kilometers, and from node A to D distance is only 3 kilometers. So I will choose this distance, that is from A to D, because it took only 3 kilometers to travel from A to D. So I chosen this route. After this, I need to travel from D to C. Distance is 1 kilometer. Total 3 plus 1, that is 4 kilometers. It took 4 kilometers to travel from source to destination. If you consider this route, from A to B it will take 4 kilometers, and from B to C it will take 1 kilometer. Total 4 plus 1, that is 5 kilometers. And from A to C it took 7 kilometers. Among these three, 4 kilometers is best. So in greedy method, we will take decision. We will choose best result on the current available information. But future information may or may not be best. So decision is not always best. If you consider another example, from A to B it will take 4 kilometers, and from A to C it will take 10 kilometers, and from A to D it will take 3 kilometers. So I chosen best result from this current available information. So I chosen from A to D because it took only 3 kilometers. But from D to C it took 5 kilometers. Total it took 8 kilometers. 5 plus 3, that is 8 kilometers. But if I choose this route, that is from A to B 4 kilometers, and whereas from B to C it took only 1 kilometer. That is 4 plus 1, 5 kilometers. Among these two, this is best route. So decision is not always best in greedy method, because we will take decision on the basis of current available information, and future information may or may not be best. Greedy method is used for solving optimization problem. Optimization problem means problem which require minimum or maximum result. For example, in before example, we need to find shortest distance, that is minimum result. So in order to solve optimization problem, we use greedy method. In greedy method, you need to understand two terms. They are what is feasible solution and what is optimal solution. Let us consider one problem. There is problem, that is, this is optimization problem. That is, I need to travel from Hyderabad to Bangalore. In how many ways we can travel from Hyderabad to Bangalore? That is by walk. This is solution 1. By walk we can travel from Hyderabad to Bangalore, and by using bike we can travel from Hyderabad to Bangalore. This is solution 2, by using bike. And solution 3 is by using car we can travel, and by using train we can travel. This is solution 4. And by using flight we can travel. By using train and by using flight. This is solution 5. These are 5 ways we can travel from Hyderabad to Bangalore. But condition is I need to reach to Bangalore from Hyderabad within 3 hours. Within 3 hours I need to reach Bangalore. In that condition, if I go by walk, I cannot reach, and if I go by bus I cannot reach, and if I go by car I can't reach. So if I go train I can reach, and if I go by flight I can reach. So these two solutions are satisfying my condition, that is by using train or by using flight I need to travel. So solution which satisfies our given condition, solution which satisfy our given condition is known as feasible solution. Feasible solution. I hope you understand what is feasible solution. Solution which satisfies our given condition is known as feasible solution. Here solution 4 and solution 5 are satisfying our condition. That is, by using train and by using flight we can reach to Bangalore within 3 hours. But there is another condition, that is I need to reach from Hyderabad to Bangalore with minimum cost. This is another condition. Among train and flight, which will take minimum cost? That is train. Train is less cost when compared to flight. So among all these solution we choose a train. This is known as optimal solution. Solution 4 is optimal solution. Optimal solution means solution which is feasible and gives best result is known as optimal solution. This train is feasible solution. Train and flight both are feasible solution. So solution which is feasible and which gives best result. Among these two, train is less cost when compared to flight. So solution which is feasible and gives best result is known as optimal solution. Now I will write general method. This is algorithm for greedy method, that is greedy of a comma n, where a is array and n is size of array. For example, in an array there are 5 elements, that is a1, a2, a3, a4 and a5. Total there are 5 elements in an array. So size of array is 5, n equal to 5, where a is array and n is number of elements in an array. For I equal to 1 to n, do, meaning of this is in an array we can include n number of elements. So I written this. For I equal to 1 to n, do x equal to select a. We need to select each and every element in an array. If feasible, if any of this value is feasible, then we need to include this in our solution. Feasible x, then solution equal to solution plus x. I'm closing this, close this and close this. Once again I will explain this algorithm. Greedy algorithm contains array, where a is array and n is size of array. For I equal to 1 to n, do, because we can include n number of elements in an array. X is nothing but we need to select each and every element in an array. And if we found any feasible solution, in before example, train and flight both are feasible solutions. So if we found any feasible solution, then we need to include this in our solution. This is meaning of this general method. Characteristics of greedy method. To construct solution in optimal way, this algorithm creates 2 sets, where one set contains all chosen items and whereas another set contains all rejected items. That is, in order to get best solution, This greedy algorithm creates two sets. One set contains chosen items and whereas another set contains rejected items. A greedy algorithm makes good local choice. Good local choice is nothing but decision is taken based on present available information. So a greedy algorithm makes good local choice in the hope that solution should be either feasible or optimal. Whatever the local choice that we have taken, that local choice will lead to feasible solution or optimal solution. For the applications of greedy method, first application is greedy method is used in finding shortest path. In order to find shortest path, we use greedy method. And next application is it is used to find minimum spanning tree. And third application is it is used in job sequence with deadline problems, and it is also used to solve fractional knapsack problem. These are the applications of greedy method. Next, components of greedy algorithm. Total there are 5 components in greedy method. First one is candidate set. A solution is created from this candidate set. Next, selection function. By using selection function, we can select a best candidate. Whatever the best candidate that we have chosen by using this selection function, this candidate is included to our solution. And third one is feasibility function. This feasibility function is used to determine whether candidate is suitable for our solution or not. And fourth one is objective function. Objective function is used to assign values to our solution. And at last, fifth one is solution function. The solution function indicates whether complete solution has been reached or not. These are the 5 components of greedy algorithm. And next topic is job sequence with deadline problem. This is an example. In this example, total there are 5 jobs: J1, J2, J3, J4 and J5. For each job there is profit and deadline. For job J1, profit is 10 and deadline is 1. For job J2, profit is 15 and deadline is 2. Similarly, for job J3, J4, J5, there is profit and as well as deadline. All these job takes only 1 hour to complete. In question, J2 and J3 deadline is 2. It does not mean that this job will take 2 hours to complete. The meaning of this deadline is job will take only 1 hour to complete, but here they given 2 hours of time. So within 2 hours of time, we need to complete this task. Similarly, for J4 and J5, they given deadline 3. That means they given deadline 3 hours. But all these job takes only 1 hour to complete. In step 1, we need to arrange these jobs according to increase in profit. Among all these, which has highest profit, that is J3. J3 profit is 20. So at first I written J3. After J3, which has highest profit, that is J2. Profit is 15. So I written 15. After this J2, which has highest profit, that is 10. So I written 10. After 10, J4, that is profit is 5 and J5 profit is 1. So according to increase in profit, I written this table. In question, for J1 deadline is 1 and for J2 and J3 deadline is 2 and for J4 and J5 deadline is 3. Among this, which is highest number, that is 3. 3 is highest. So maximum deadline is 3. So we need to take 3 slots. Slot 1, slot 2 and slot 3. Here deadline is 3 hours now. So for slot 1, 1 hour. For slot 2, 1 hour. And for slot 3, 1 hour. Total 3 hours of time. From this table, for job J3, deadline is 2 hours. So I can place this J3 either in first slot or in second slot, because all these slots are empty. Whenever 2 slots are empty, try to place job in second slot. So I am placing job 3 in second slot, J3 in second slot. Similarly, job J2. Yet for job J2, deadline is 2 hours. So I can place this in this slot or this slot, but this slot is already given to J3. So I am placing this job J2 in first slot. Similarly, for job J1, deadline is 1 hour. That means within first 1 hour, I need to complete this task. But I already given this first hour to job J2. So I cannot consider J1. Now J4. For job J4, deadline is 3 hours. That means I can complete this job J4 either in first slot or second slot or in third slot. But slot 1 and slot 2 are already filled. So I need to consider slot 3. So now I am placing J4 in slot 3. I assigned jobs to all the 3 slots. So no slot is empty. So now I can stop this. I consider job J2, J3 and J4. I placed J2 in slot 1 and J3 in slot 2 and J4 in slot 3. And profit of J3 is 20 and profit of J2 is 15 and profit of J4 is 5. So total 40. Total I got profit 40. This is example of job sequencing problem. This is another example. In this example, total there are 5 jobs: J1, J2, J3, J4 and J5. In step 1, we need to arrange this table according to increase in profit. Among these jobs, which has highest profit, that is J2 has highest profit. So at first I took J2. And similarly after J2, which has highest profit, J1, profit is 30. So after that I written J1. After that J3 has highest profit, so I written J3. After that J4, profit is 5, and after that J5. So I took this table according to increase in profit. Here maximum deadline is 4. That means 4 hours. So I took 4 slots. Each slot occupies 1 hour. For job J2, deadline is 4. That means for job J2, they given 4 hours of time. So these 4 slots are empty. So I am placing this J2 in slot 4. Similarly for J1, after J2, J1. For J1, deadline is 1. That means within first 1 hour, I need to complete this task. So I am placing J1 in first slot. And after J1, J3. For J3 also, deadline is 1. That means within 1 hour, I need to complete this job J3. But already I assigned this slot 1 to J1. So I cannot place this J3. And similarly for job J4, deadline is 1. That means within first 1 hour I need to complete this J4. But I already assigned this first 1 hour to J1. So I cannot complete this J4, and similarly I cannot complete this J5. So for J2 profit is 40 and for J1 profit is 30. Total 70. Total profit is 70. And next topic is fractional knapsack problem. Knapsack problems are classified into 2 types. One is fractional knapsack problem and next one is 0-1 knapsack problem. This fractional knapsack problem follows greedy method. In this we can break items. For example, there are 3 kgs of potatoes with me. So in that 3 kgs I can select 1 kg of potatoes. That means I can break these items. But in 0-1 knapsack problem we cannot break items. For example, there is television with me. I cannot break this television. This is an example. In this example, total there are 7 objects, and for each object there is profit and weights associated with it. Here there is 15 kgs of bag with me. In this I can place items such that size should not increase more than 15. If I place all these items, then size will be higher than 15. So that I need to select only items with highest profit. For this object 1, for 2 kgs profit is 10. That means per kg how much? We need to calculate that. For 2 kgs profit is 10. That means per kg profit is 10 by 2, that is 5. And for 3 kgs profit is 5. That means for kg profit is 5 by 3, that is 1.3. 15 by 5, that is profit is 3. And 7 by 7 profit is 1. And 6 by 1 profit is 6. 18 by 4 profit is 4.5, and 3 by 1 profit is 3. This is highest profit per kg. How we calculated this profit per kg? That is profit by weight. Among all these objects, which has highest profit? That is 6. 6 is highest profit per kg. So I am selecting object 5. Profit is 6 and weight is 1. I placed this object 5, weight is 1. So remaining weight is 14 kgs left. After object 5, which has highest profit? That is 5 is highest. So I am selecting this object 1. Object 1, profit is 10 and weight is 2. 14 minus 2, that is 12. So remaining 12 kgs left. After this 5, which object has highest profit? That is 4.5 is highest. So I am selecting object 6. Object 6, profit is 18 and weight is 4. After placing this object 6, that is 4 kgs, how many kgs left? That is 8 kgs. After this 4.5, which is highest? 3 or this? Either I can place object 3 or object 7 because both has same profit. You can select anyone. I am selecting this object 3. For object 3 profit is 15 and weight is 5. After this, which has highest profit? That is object 7. So I am selecting object 7. For object 7, profit is 3 and weight is 1. 8 minus 5, that is 3 kgs left. After selecting object 7, 3 minus 1, that is 3 minus 1, that is 2 kgs left. Here next, which object has highest profit, that is 1.3 is highest. So I am selecting this object 2, but here only 2 kgs left, but here weight of this object 2 is 3 kgs. So I cannot place entire object. So I need to divide this into fraction. That is, out of 3 kgs, I am selecting only 2 kgs. That is 2 by 3. That is, out of 3 kgs, I am selecting only 2 kgs. So for this object 2, weight is 3. But I am selecting only 2 kgs per 3. That is 3 into 2 by 3. And similarly, profit is 5. 5 into 2 by 3, that is 3 cancel, that is 2, and 5 into 2 by 3, that is 1.3. Now we need to calculate this total weight. We should get 15. 2 plus 1 3, 3 plus 4 7, 7 plus 5 12, and 12 plus 1 13, 13 plus 2, that is 15. Total 15 kgs. Now we need to calculate profit. That is 10 plus 6 16, 16 plus 18 34, 34 plus 15 49, 49 plus 3 52, 52 plus 1.3, that is 53.3. This is total profit. This is how we calculate fractional knapsack problem. And next topic is minimum cost spanning tree. And also I will explain what is Prim's algorithm and Kruskal's algorithm. At first I will explain what is spanning tree. Spanning tree is nothing but it is a subgraph that contains all vertices and minimum number of edges. And this spanning tree is undirected graph that does not have any cycle. I will give one example so that you can clearly understand. You can define graph G as V comma E, where V stands for vertices and E stands for edges. This is graph. In this graph, 1, 2, 3, 4 are vertices. We can also call these vertices as nodes. And these nodes are connected by edges. These lines are known as edges. Now let us find what are the possible spanning trees for this particular graph. These are the 4 possible spanning trees for this particular graph. I already said spanning tree contains all vertices. See, in this there are 4 vertices. So this spanning tree also contains 4 vertices. But it contains minimum number of edges. Whereas in this graph total there are 4 edges. But spanning tree contains only minimum number of edges. Here for this spanning tree total there are 3 edges. And this spanning tree is undirected graph. Undirected graph means graph which do not contains any directions. For example, this is directed graph. That means we represent this edge by arrow mark, is known as directed graph. But in spanning tree it must be undirected. And it should not contain any cycle. For example, if I select this edge, then it will form cycle. So we should not select this edge. So total there are 4 possible spanning trees for this particular graph, and it must be undirected and acyclic. This is one more example. For this particular graph, it contains 2 cycles. One is this and another one is this. Now we need to find spanning tree for this particular graph. A spanning tree is nothing but it is a subgraph that contains all vertices and a minimum number of edges. This contains all vertices. Total there are 4 vertices here. 1, 2, 3, 4. So this subgraph contains all vertices and minimum number of edges. Here for this graph total there are 5 edges, but this graph contains only 3 edges. So it must be minimum. For example, if I connect this, then it forms a cycle. So I should not select this edge. Similarly, if I select this edge, then again it will form cycle. So we should not select this edge. Always it must be acyclic, and it is undirected graph. For example, it has arrow mark, then it is considered as directed graph, but it must be undirected graph. Now let us discuss what is minimum cost spanning tree. Minimum cost spanning tree is a spanning tree that contains minimum weighted edges. I will give one example so that you can clearly understand what is minimum cost spanning tree. For example, this is a graph. For this graph, each edge contains some weights. So now we need to find minimum cost spanning tree. So for this, at first we need to find possible spanning trees. What are the possible spanning trees for this graph? 2, 3, 5, 3, 4. This is one spanning tree. This is another spanning tree. Guys, if I connect this 2 and 4 vertices, then it will form a cycle. So I should not connect this. This is another spanning tree. So these are the possible spanning trees for this particular graph. Now we need to find minimum cost spanning tree. So total cost of this particular graph is 4 plus 5 plus 3, that is 12. And similarly, total cost for this graph is 5 plus 4 plus 6, that is 15. So we need to find cost for all these graphs. Among all these graphs, this graph cost is minimum. For this particular graph, cost is minimum, that is less. 4 plus 1 plus 3, that is 8. So this is minimum cost spanning tree. Among all these spanning trees, this is minimum cost spanning tree. This is how we will find minimum cost spanning tree. But finding all possible spanning trees and then calculating total cost for this spanning trees is time taking process. So for this purpose we use Prim's algorithm and Kruskal's algorithm. At first I will explain Kruskal's method. In Kruskal's method, we will keep on picking smallest weighted edges. But if that edge forms cycle, then we will not select that edge. So we will repeat the same process until we form minimum spanning tree. I will give one example so that you can clearly understand Kruskal's method. For example, this is a graph. Now we will find minimum cost spanning tree for this graph by using Kruskal's method. Kruskal's method always says that select the smallest weighted edge. Among all these edges, which are smallest weight, that is this one. One is smaller. So at first I will select edge 1. So I will connect B to A. Weight is 1. After 1, which is smaller, 2 is smaller. So I will select this. Weight is 2. After 2, 3 is smallest weighted edge. So here B to C weight is 3 and from A to C weight is 3. So I can select either this or this. So I will select this. After 3, which is smaller, this one now. But I will not select this because if I select this edge, then it will form a cycle. So we need to ignore this. We need to select smallest weighted edge. But whenever that edge is forming a cycle, then we should ignore that edge. We should not select that edge. After 3, which one is smaller? That is C to D. Weight is 4. So I will connect this. And after this, which one is smaller? 5. But if I connect A to E, then again it will form a cycle. So we will stop this here. So total weight is 3 plus 1, that is 4. 4 plus 4, 8 plus 2, 10. Total weight is 10. This is minimum cost spanning tree. This is how we will find minimum cost spanning tree by using Kruskal's method. Next, let us discuss Prim's algorithm. Guys, you need to remember one thing, that is we can find minimum cost spanning tree only for connected graph. Connected graph means there should be connection between each and every nodes. For example, if you consider this graph, we cannot find a minimum cost spanning tree for this graph because it is not connected graph. Next, Prim's algorithm. In Prim's algorithm, at first we need to select any single node and then we should keep on connecting the adjacent nodes until we find minimum spanning tree. I will give one example so that you can clearly understand. For example, this is a graph. Now we will find minimum cost spanning tree for this graph by using Prim's method. At first we need to select any single node. For example, I am selecting node B and then we should keep on connecting the nodes. Keep on connecting the adjacent nodes. What are adjacent nodes for this node B? This B is connected to node D and node C. So D and C are adjacent nodes. Among these two, which are smallest weight? That is 5 is smallest. So I will select this edge. I will connect B to D. Weight is 5. What are adjacent nodes for BD? That is node B is connected to C. So adjacent node is C. And similarly D is connected to C and E. So among these three, which is smaller? 1 is smaller. So I will select D to E. Weight is 1. And after 1, I can select 2 connected to C. And adjacent node for this C is A. So I will connect this C to A. Weight is 3. If I connect to B to C, then it will form a cycle. And similarly, if I connect from C to E, it will form a cycle. So I can stop this here. So total weight is 5 plus 2 plus 1 plus 3. That is 11 units. Guys, it is very simple. We should keep on connecting the adjacent nodes with minimum weights until we form a minimum spanning tree. If that edge form a cycle, then we should ignore that. And next topic is Dijkstra's algorithm. This is one of the example of single source shortest path problem. Shortest path problems are classified into two types. One is single source shortest path problem and next one is all pair shortest path problem. Example of this single source shortest path problem is Dijkstra's algorithm. And whereas example of all pair shortest path problem is Floyd-Warshall's algorithm. In single source shortest path problem, initially we need to select one single node as source node. From that source node, we need to find shortest distance for all other nodes. I will give one example so that you can clearly understand Dijkstra algorithm. Single source shortest path problem. Single source means we need to select one source node, single node. So I am selecting this node 1 as source node. Now initially mark all other nodes as infinity. That means we did not visit all these nodes. So I am marking this nodes value as infinity. Now from node 1 to node 2, distance is 2. So replace this infinity with 2. I visited this node 2. Similarly, from node 2 to node 3, distance is 4. So we need to replace this infinity with 2 plus 4, that is 6. And similarly, distance from node 3 to node 4 is 6 plus 6, that is 12. So I am replacing this infinity with 12. Now I visited this node 2, node 3, node 4. I visited all the nodes. So distance from node 1 to node 2 is 2, and distance from node 1 to node 3 is 6, and distance from node 1 to node 4 is 12. Now we visited all other nodes. This is single source shortest path problem. Worst case time complexity of Dijkstra algorithm is theta of n square. I will give one example. Initially in step 1, I am selecting one source node. For example, I am selecting source node as this node 1. This node 1 is source node. Now we need to mark all other nodes as infinity because we did not find shortest distance. So I am marking this distance for all other nodes as infinity, infinity and infinity. Meaning of infinity is unvisited. I selected this node 1 as source node. This source node is directly connected to node 2 and node 3. So distance from node 1 to node 2 is 2. So I am replacing this infinity as 2. And similarly, distance from this node 1 to node 3 is 5. So I am replacing this infinity with 5. This node 2 is connected to node 3 and node 4. So distance from node 2 to node 4 is 2 plus 8, that is 10. So I am replacing this infinity with 10. I visited this node 4. I already visited this node 3. Value of this node 3 is 5 because from 1 to 3 distance is 5. So I given this value of 3 is 5. But distance from node 2 to node 3 is 2 plus 1, that is 3. 3 is smaller than 5. So I am replacing this 5 with 3. Now node 3 is connected to 5. So distance from 3 to 5 is, distance of this 5 is 3 plus 3, that is 6. So I am replacing this infinity with 6. I already visited this node 4. Distance of this node 4 is 10. But node 5 is connected to node 4 and node 6. So distance from this node 5 to node 4 is 6 plus 2, that is 8. So 8 is smaller than 10. So I am replacing this 10 with 8. And similarly, distance from this 5 to 6 is 6 plus 5, that is 11. So I am replacing this infinity with 11. But from this node 4 to node 6, distance is 8 plus 1, that is 9. 9 is smaller than 11. So I am replacing this 11 with 9. Now we visited all the nodes. This is shortest distance from node 1 to all other nodes. Now we need to write table for this. Distance from node 1 to node 2 is 2. So here we need to write 2. And similarly, distance from node 1 to node 3 is 3. And distance from node 1 to node 4 is 8. And distance from node 1 to node 5 is 6. And distance from node 1 to node 6 is 9. We selected one single source node as node 1. And we found shortest distance to all other nodes. This is single source shortest path problem. Guys, you may get doubt like from node 2 to node 4 distance is 8. But why we are counting this value? Because you are finding shortest distance from node 1 to node 4. So that we need to count both this 2 and 8. Guys, in exam don't write like this. Write this graph in step by step manner. Like this you need to write. For each visit you need to write one graph. This is an algorithm. Initially step 1 is start. After that in step 2 we need to select one source node. After selecting source node in step 3 we need to assign all other node values as infinity except that source node. And in step 4 we need to find shortest path from this source node to all other nodes. Once we found shortest path to all other nodes, step 5 is stop. This is algorithm. There is one disadvantage of this Dijkstra algorithm, that is visited node is never checked again. That means once we visit that node, once we perform relaxation, we should not check that node again. This is disadvantage.